before I forget. Okay, so we need to use the table to see the activity of the single element. Now, in the first example, we have zinc plus water reacting under a temperature of 50 degrees Celsius. So, to understand if this reaction will occur or not, we need to not just see the table, but also read about the reactivity. The reactivity is written here, okay? That's what is about the reactivity. Now, we need to focus on the single element. In this case, is zinc. So zinc in the table is right here. That means that is in the second group. Okay, I don't really care about what group it belongs to. What I do care is this. It says that it reacts with steam, but not cold water. And also reacts with acids. When reacting with acids, it replaces hydrogen. It can also react with oxygen, forming oxides. That is important. And first, we need to also see what is steam and what is cold water. Scientific terms, okay? Cold water is not necessarily water from the fridge, okay? It is water at any temperature but 100 degrees Celsius. So, here's one thing that you need to know about water. I'm gonna write it right here. Water has two main temperatures. At 0 degrees Celsius, it becomes ice, okay? It freezes into a solid. But water at 100 degrees Celsius, it begins to boil, okay? Now, boiling is going to cause steam, okay? So, steam will only occur if you have water which is boiling. That means that steam can only occur when you have 100 degrees Celsius going on in the reaction. Now, if you have any other temperature, okay, below 100 Celsius is going to be known as cold water.
Even if it is 99, miss?
Even if it's 99, chemically it's cold water. Okay? So that is very important that we know the difference. Okay? So I'm going to up to 99 better. Okay? So if you have a temperature of 99, it's cold water. If you have a temperature of 105 Celsius, it's steam. Okay? If you have a temperature of 50 degrees Celsius, which is the case right here, then this is known as cold water. That's how you identify how hot chemically the water is. Now, again, I need to read the paragraph about the reaction. It says that it reacts with steam but not cold water. That means, but not cold water, that means that in this exercise, we have no reaction because the water is cold. So zinc is not going to react. So all we need to do with this exercise is writing an R to indicate no reaction. because that's the case. Now, if the exercise indicates 100 Celsius, then yes, we would need to do to predict the product by doing this that says replacing hydrogen. Okay, so in this case, no reaction because it was just 50 degrees Celsius. But as I told you, what if we had a temperature of 100? So I'm going to do the example, the what if example instead.
If we have 1 degree, means it's gonna be cold water, right?
Yes. But I'm going to write it again. So, what if the temperature was 100 Celsius degrees instead? So, going to do the example. Zinc plus water at a temperature of 100 degrees Celsius. So, what is going to occur? Okay, so now that we do have the temperature of 100 Celsius, that means that it is steam. Okay, if it is steam, that means that reaction will occur. Okay, so reaction takes place and I need to see what is going to be produced. So I'm going to follow what the table tells me that is going to happen. So here it says reacts with steam and acids replacing hydrogen. I will take with that part only because this is the example that applies right here. Reacts with steam and acids. It's not an acid, but reacts with steam, replacing hydrogen. So what I need to do, that table is already telling me what to do. I need to replace hydrogen. So the replacement right here is going to occur between zinc and hydrogen. Okay? So now hydrogen is going to be alone. In hydrogen you have to think, is this a diatomic element?
Yes.
Yes. So you need to include these two as a substrate. Do not forget. So hydrogen, which is diatomic, we have always two as a substrate. And zinc is going to be combined with oxygen. So what is the charge of zinc according to the periodic table and what is the charge of oxygen?
Zinc is 2
Zinc
and
is
oxygen -2.
okay, plus 2, -2. It means that the charges here will be cancelled. So this is the product that is going to be formed. Okay. So my reaction will end up like this. Zinc plus water. Okay. Is going to produce H2 plus zinc oxide. It's going to produce hydrogen gas and zinc oxide. Now, as usual, I need to see if it is balanced. Just by taking a look, I already know that it is balanced. 1 zinc, 2 hydrogens, 1 oxygen. In the products, I have 1 zinc, 2 hydrogens, and 1 oxygen. So that means that this equation is balanced. But not all of them are going to be balanced. So it's good that you check that it is balanced. Any doubt on the first example? Okay. In the second example, we have solid tin plus oxygen gas. Okay. Guys, another thing very important in this first example. Take a look here in the sample problem. Take a look. The temperature of the water also will define the physical state. So when the water is at 0 degrees, you have ice, which means that's solid. Okay. Steam is a gas, and cold water is going to be liquid. So that's another thing to identify the physical state of the physical state slash temperature of water. In this case, the problem is giving you a temperature of 50 Celsius, but also telling you that it's liquid. Okay, it's liquid. I didn't write a physical state in the example, but you can see it right here. It is liquid. So, not just by the temperature, also by the physical state, you can tell that it is cold water, which means that no reaction occurs in the first one. So that is very important. Because if you see, even if the exercise, for example, doesn't give you any temperature at all, okay? Imagine that it doesn't give you any temperature. So what do you have to see? The only key to know how the water is the physical state. So, as it is liquid, you will know that then it is cold water, just because it's liquid. Now, if instead of L you have G, you know then that it is steam. Gas is steam, so the temperature is 100 Celsius, so everything changes in the exercise. That is also very important to be to be analyzed from this point of view. That's not the case, but just in case that you have your exercise written like that, you should know what to do with that. That's why I'm giving you temperature, physical state of each. Now let's work with the example number 2. Thin solid or solid thin plus oxygen gas. Okay? So again, what we need to see is the single element. Okay? Thin. Now let's take a look to the table. In what group do you find tin? First, second, third, fourth, and fifth.
Third.
In the third. Okay, so let's analyze. Okay, we have tin right here in the same group as cobalt, nickel, and lead. It says, do not react with water. Well, it's here in this example, it's not reacting with water, okay? It reacts with acid replacing hydrogen. Oxygen is not an acid. But then it tells me what happens if you have an oxide or oxygen. It says react with oxygen, forming oxides. This is the situation that is going on in this reaction. So, tin, do not react with water. I don't care in this moment. React with acids. I don't care in this moment neither. But react with oxygen. Yes, I do care because the reaction includes oxygen. So it says reacts with oxygen forming forming oxides. So what is going to occur is just um, compound formation, okay? In this case, thin is not specified, the, the charge to be used, but I will tell you to use tin 4, okay? So when you form the compound, you're going to have tin with a charge of positive 4 and oxygen with a charge of negative 2. So what is going to happen is you will crisscross the charges, swap the charges, so you will have 2 O4. And what you have to see after is can you
simplify.
simplify exactly? So you have 2 over 4
1 and 2.
is going to be invisible 1 over 2. So it's going to be Sn invisible 1 O2. Invisible 1 O2, that will be the final product. So my reaction will be like this, Sn plus O2, producing what you have over there. And just by taking a look, we know that it is balanced, okay? Or you can even compare to what you have in the reactants against what you have in the products. So as you can see, yes, it is balanced. Let's try the third example. That solid cadmium plus lead 2 nitrate in aqueous solution. So I'm going to write it down. Give me a second, please. Okay. So this is what I have in the third example. Cadmium solid cadmium plus lead 2 nitrate. I want to see if it is reactive. Okay. Now take a look. Cadmium is alone, so I'm going to focus on cadmium. Okay. And here, lead is the other metal in the reaction. So I need to compare, here I need to compare the position of them. Remember the example I gave you the other day. So we're going to focus on cadmium. Cadmium is in the same group as zinc. Okay, there it is, cadmium. So I need to focus on the position between cadmium and lead. There it is, lead. So can cadmium replace lead? Yes or no?
Yes.
Yes, because it's located above lead, so yes, the reaction will occur. It will replace it. So what we do is we swap the position of them. Now lead is going to be single. Se quedó single. Qué bárbaro ese cadmium. Esto no era. And now we combine cadmium. According to the periodic table, what is the charge of cadmium?
2. 2.
Plus 2. It happens just like zinc, okay? It's plus 2. And you will combine it with the ion nitrate. Nitrate, it is in the table of polyatomic ions that I give you. The charge of nitrate is negative 1. So you will crisscross the charges. Okay, so you will have cadmium Well, the charge of 1, you don't need to change it because it is invisible. Just ignore it. But the charge of 2, it comes right here. But we cannot leave it like that.
Parentheses.
To place parentheses. So, the reaction occurs? Yes. What is a product? Then this is the product. Ay, no sé por qué no me deja. So I'm going to write it again. A lazy person like me hates this moment. From all my heart, I'm telling you. Esta cosa. Okay, now we do is we check if the equation is balanced. So we list the elements, metals first, then non-metals like nitrogen, and the very last is oxygen. I have 1 cadmium here, 1 lead here. I have a 1 times 2, 2 nitrogens, and 2 and 3 is 6 oxygens. In the other side, I have 1 cadmium, 1 lead, 2 nitrogens, and 6 oxygens. So my equation is already balanced. Now let's try the last example, copper plus hydrochloric acid. Copper plus hydrochloric acid. Let me just write it. Solid copper of course, acrylic acid. Okay, so this is the example. So I need to see if this reaction will occur. To see if it is capable to occur, what I need to do is I need to see the single element. Okay, copper. So I'm going to look for copper. Copper right here is reacting with HCl, which is hydrochloric acid. That's why naming is important, okay? Because you know now that you are combining copper with acid. So you need to see if the reaction will take place with an acid, okay? So we need to see the reaction. We need to look for copper in the table. In what group do you find copper?
In the fourth.
Okay, in the 4th. Copper is right here. Okay, copper is right there. I'm gonna use another color instead. Okay, copper. What I know about copper is that the only possible reaction is with oxygen forming oxides. Are we combining copper with oxygen?
No.
It's an acid. It doesn't say anything about acid. So, what we can also do is the acids begin with hydrogen. So you compare the position against hydrogen. So there are 2 reasons to believe the reaction won't occur in this example. 1, because it doesn't say anything about acids right here. Nada about acids, okay?
The position of hydrogen.
Also the position of hydrogen. So you have 2 reasons to know that this reaction won't take place, okay? So it doesn't say anything about acids, but hydrogen is above, so it cannot be replaced by copper. So what we say is no reaction. Imagine a reaction that simple. I remember like 2 or 3 years ago when we saw that topic for the first time, and we did a quiz. So you have special students at all times. You have very special ones that are those that get 100, and are the other in the other side of the scale that you have the other students. So I remember one student used to write no reaction in all. What are the odds that Martinez uses 5 no reaction exercises in a quiz? I mean, the odds are not good. At least he got 1 out of 5. So don't do that. I would never gonna leave you with no reaction example. That would be very boring. Okay, to write no reaction in all. But you can expect one or even two in a homework of 10 exercises. More than that, So, so you have to see how the reaction occurs. Now, taking a look to the table that I gave you, is this reaction going to occur?
We need to check the table.
No, it won't. No.
No. Just take a look to the one that is going to be replaced. Lithium is the one that is in the very top of the table, so that means that lithium cannot be replaced under any circumstance. Okay? So, this, no reaction. What about lithium with acids? Is this reaction going to occur?
Yes.
Yes.
Yes. So that means that lithium and hydrogen are going to swap positions. Hydrogen now it will be alone, so hydrogen is the atomic, and lithium will be combined with chlorine. Lithium has a charge +1, chlorine of -1, so that means that they're going to be cancelled. And what you do after is checking if the equation is balanced. If not, you do the balancing process. 1, 1, 1, 1, 1, 2. I place 2 right here, but also changes my chlorine. Put 2 right here, and I put 2 right there.